Hi everyone, and welcome to today's video. In the previous 3 videos of this series, we have set up the React front end for our social media application. We added support to Webpack, TypeScript, Jest, React testing library, Cypress, ESLint, Prettier, and pre-commit hooks. But there is something missing. We didn't really build our files for production. And that's exactly what we're going to do today. We are going to set up the production script and the small Docker file to build our production assets and ship them with a basic nginx server. But I repeat, of course this is not the final production setup, it's just to give you an idea of the workflow behind it. Let's then jump to the agenda for the video and we'll start working. Here's the agenda for today. We will start by merging the dependency updates branch into master. We will then update our App.tsx file to show whether we are in development or in production, and this depends on the value of that node_env environment variable. We then create a script to build the production bundle, and we will implement a basic Dockerfile to run the production version. Now, you could do it as you want. You could install a new npm dependency, for example, that would spawn an HTTP server to serve the files. Here we are going to do with a basic Docker file and a simple nginx configuration. Of course, this wouldn't be the final configuration in a production server, but here I just want to show you how to deliver the files that are created by our production script. Before we merge the dependency updates branch into master, I just want to show you that there are quite a few changes that happened since the last time we merged it. As you can see, there are many patch updates and a few minor updates, as well as a few dependencies being pinned. So let's go to the terminal and merge this branch into master. Back at the terminal, let's make sure to pull the latest version of master and to check out the dependency updates branch so that we can now pull also the changes here, and we can check out, create a new branch that is going to be used for the merge so that we don't delete the dependency updates branch. So here I'll just call dependency updates. Yes, that's correct. And here I need to add a -b because this branch is not existing yet. So here I will push this again to the remote. And now let's go back to GitHub to finish the merging process. Back at GitHub, I will compare and create a pull request with the branch that I just pushed. Nothing different here, core dependency updates. And I'll click on create pull request. Before we finish the merging process, I just want to show you one interesting thing here. As you can see, we have quite a few commits that were already merged into master. Now these commits are being shown here because they come from the dependency updates branch. So I'm thinking if it would make sense to merge the dependency branches directly into master, get it deleted automatically by GitHub, and then simply recreating it immediately after so that Renovate can continue to work on the dependency updates branch, and we don't have this polluted history, right? So I'll think about it, and in the next round of updates, I'll come up with a conclusion here, and we'll just discuss what are the options, what we can do to have a cleaner history of commits. It may be the case that it's easier to simply merge the original branch, not lm/, but just the dependency-updates branch, and have it deleted, and then we create a new branch from master and we have a clean history of commits. I think this would be the cleanest way to go, but in the next round I'll come with a conclusion. So all the checks already passed here. I'll simply squash and merge these updates, and once I do that, then master is going to have the latest version of our dependencies. Back at our terminal, I can now check out master, pull the new version, and simply merge this into our dependency updates branch. And here I think we will also benefit from deleting the dependency updates branch, because here we are always merging master back, but if we delete it, we can create a new branch from master. So here I can simply push this to the origin and everything should be up to date. Okay, I have changed my mind very quickly, and I have also made up my mind. I don't like the fact that the dependency updates branch has a very polluted history of commits. If I were to come here and have a look at the dependency updates branch, you will see that it says it is 44 commits ahead of master. The problem is that the changes here are really, there are no changes. So if I were to come here to dependency updates and to create a pull request to master, so let's come to pull requests, and then we will create a new pull request, and we will compare the dependency updates branch. Oops. Dependency updates, exactly. Then it will say that there are no changes, right? 0 changes with 0 additions and 0 deletions, even though it says that there are 44 commits ahead of master to be merged. Now, this is not really nice because it's very polluted history and I personally don't like it. So we will go with our second approach, where we will merge the dependency updates branch directly into master, let it be deleted, branch from master and recreate it again, and then we will push it to the remote repository. Here, since we have no changes whatsoever or no differences, I will simply delete this branch, and from the terminal I will branch again from master and push it to the remote repository. But before I can delete this, I need to come to there is one open pull request, which is a major update, and I still didn't merge this. We'll simply delete this. So I will mark this pull request as closed. Now that I marked this pull request as closed, I can come back to my branch, the dependency updates branch, and I can finally delete it. So here in the red button, let's delete this one. The dependency updates branch is gone. Renovate is not going to update anything if I don't create a new dependency updates branch. So let's do this now in our terminal. Let's check out master. Let's delete our local dependency updates. And we will now branch again from master. So git checkout branch dependency updates. And here I'll simply push this to origin dependency updates. Once the process is done, as you can see, the dependency updates branch now is new, right? It's even with master. This is much nicer because this will allow us to have a much cleaner history of this dependency updates branch. So it's a small update. I just thought we would do it on the fly. I know this is not on the initial scope of the video, but just thought that would be nice to have this discussion right now. So let's go back here and mark the merge dependency updates branch as completed. We will go now to the IDE and we will update our app.tsx file. But before, let's go back to the terminal and let's check out a new branch so that we can work on the features of this video. Back at my terminal and in the master branch, let's check out a new branch. This is going to be called, let's say, production setup, right? This would be for the web client, but would be too long of a name. We'll just call this production setup. Let's come now to the IDE and we will start working on our web client. Now, of course, there are a few new dependencies here, so we need to install them. I know this is getting a little bit cumbersome to always run npm install in each of the directories. So in the next few videos, I'm not sure if in the next one, but I think so already, we will add some scripts to automate this. So we will have a couple of scripts that we can run in the root directory that are going to execute the npm CI script in each and every subdirectory that has a package.json file. For now, let's go back to the terminal. Let's change into the auth directory. We will run npm CI. That's just to make sure that we have the latest dependencies there. I mean, we are not going to work on the auth directory, but I just want to keep it up to date. Once this is done, let me clear the console and now we'll change to the web client directory and we'll do the same. Perfect. With all the dependencies up to date, let's go back to our IDE and let's open the app.tsx file in our web client directory. Oops, not the index, but the app.tsx. I will also spawn up an instance of our development server so that we can see our application as we make the changes here in the IDE. Back at my terminal, I can simply run npm run start :dev, and this will spawn our development server and serve the files in our browser. This is the output of the command, and if I were to access localhost colon 9000, I would see this unsocial app in my browser. So let's go to the IDE now, and we'll try to show this process.env.node_env variable. So instead of returning an h1 here, let's return a div. And here I need to close it. Below this h1, we will add a new one, h2. Let's call it like this. And we'll say we are in process.env.node_env. Okay, so you just say, okay, we are in, we'll say either development or production. I'll save this and let's go back to the browser. Perfect. Then it says we are in development, and here I don't need this dollar sign. So if I save this again, the dollar sign should be gone, and we'll say we are in development. One quick note, some of these underscore red lines here are because of prettier, but this one we are interested in. So it says it cannot find the name process. So we actually need to install the @types/node package in our project as a development dependency so that we can have access to the node types. I will copy this command, and back at my terminal, I'll stop the development server and I will run the command npm I savedev @types/node. Once I run this, then it should be possible for us to get rid of that underscore or that red underline that is in our IDE. One more little thing we need to do here after installing the package is to add node to the types field in our tsconfig file. Let's come here to the tsconfig, and next to jest we'll simply say node. Now if we come back to our app.tsx, the error should be gone. This completes the second part of the video. Let's now create the script to build the production bundle. Back at the IDE, I just opened the webpack.config.js file, and here, just as a reminder, we will output the bundled files into a dist folder, and they will be called bundle.js. Now here I'm not doing any code splitting, I'm not doing chunking, I am not doing any optimization. That's okay for now. Maybe later in the future we will talk about this in details. For now we will just output one single bundle.js file. But how do we actually execute the Webpack build command? Well, it is really simple. It's as simple as running Webpack, but remember I need to run from within my .bin folder of my local node modules, and I'll run just Webpack like so. Once I run this, you see it's gonna take a while and it's gonna output a few things on the screen. But if I come back to my IDE, you will see that there is a new dist folder created. Now within this dist folder, there is a bundle.js file, and there is an index.html file. If I open the index.html file, you will see that there is a script tag here, which says, okay, source from bundle.js file, and bundle.js file, it's gonna look a little bit ugly, but this is our application. This is all we need to do to build the files for production. Now, of course, maybe later on we will have a few other checks or a few customizations that we will add to the files, but in the end the process is going to be the same. Just run Webpack, get this dist folder, and then serve it via some HTTP server. So let's add this command to our package.json file. Here we will add this as the build command, we'll call it like so, and we will say node_env equals production. We'll simply call Webpack without the serve here in the end. It's just a Webpack executable that we want to run once we run the build command. So just to see if this is working, I will delete the dist folder again. I'll come back to my IDE, clear the console, and then say npm run build. And this should run the Webpack. Of course, I need to save the file first, right? So I just save the file and then I run the build command. Perfect. Now we have a command in our npm, so in our package.json file that we can use to build our application. This completes the third part of the video, and now comes a more interesting part. We have a bunch of files. We want to deliver these files, but how do we actually deliver the files to our users? Now you will need an HTTP server, right? So there are many choices out there. I will simply go with nginx for this setup here. I want to create a Dockerfile that is able to build our application and then serve it via an nginx server. Today's implementation will of course not be the final version, but I just want to show you how we can bundle this whole process together in a Dockerfile that we can then use somewhere else to actually ship the application. Back at our IDE, let's create a new file within the web client root directory, not inside the source folder, but just under web client. Let's create a new file and we'll call this Dockerfile. I'll add this to Git. I mean, doesn't make that much difference. I want to commit it here, but for our purposes, we will just run this locally. Our Dockerfile will have two steps. Step number one is we want to build the production version of our application. And step number two, we want to serve the production files via an HTTP server. This is going to be a multi-stage Dockerfile, and for the first stage, we want to pull the image from the Docker Hub, the Node Fermium Alpine image. Now, Fermium is the 14, so Node 14 stable version, and Alpine is a smaller version than the whole Node image, right? So we don't need all the features from Node here. We need just the bare bones. So the Alpine version is going to suffice. Then in the end, we have a smaller image size once we build this image with Docker. Before we start copying anything, we want to define the work directory or working directory. This is going to be /app, like so. And then we can copy our dependency files. So copy dependencies, copy and install. Let's call it like this, and install dependencies. This is going to, the only files I need to copy here are the package.json and the package/lock.json file. And I want to copy these files to the dot directory. Oops, sorry, should be like so. And then I want to run the command npm ci. After the dependencies are installed, I now want to copy the remaining files. So copy files necessary for production. And why do I copy these files afterwards? Well, the reason is quite straightforward. So Docker works like this. So every time we do a change to a certain part of our build process, so let's say each command here is a step in the build. Every time we do a change to a certain command or to the files of a certain command, Docker is going to execute all the commands after the change. So if we change, for example, the package or the package-lock.json file, Docker will always execute the npm ci command from start, so from zero. It's not going to take any cached version of it. If we copy the production files together with our package.json or our package-lock.json file, every time we change some code inside of our source directory, Docker is going to run this npm ci command again. Now, of course, our dependencies are not going to change as often as our code will, so we don't really want to always execute npm ci every time we need to build a new Docker image. So we want to simply cache this step of our build process and use the cached version of npm ci as long as our package.json or our package-lock.json files don't change. So here, let's copy the files that we need. The first files we need to copy are of course, the Webpack config file. We also need to copy the tsconfig file. So tsconfig.json, and another file that we need, which is very important, is the .babel.rc file. Okay, so these files we need to copy to our final directory, and this is going to be, the command is going to copy these three files so that it can properly execute Webpack. Of course, why do we need the .babel.rc file? If I open Webpack here, you will see that for tsx files, we are going to use the Babel loader. So we need to have this Babel.rc as the configuration for our Babel library. So after copying the individual files, we can now copy the two directories that we need. We need the source directory, and we're going to copy this into the source directory. We'll also copy the public directory into the public directory. And why do we need the public directory? Well, the public directory is the one that hosts our index.html template, right? So if we open the webpack.config file, you will see, okay, look for a file in the public /index.html, or look for an index.html file in the public directory and output an index.html file within the dist folder. So this is the file name manifestation of this configuration, and the template is going to look within the public directory. This is why we need also to include the public directory when copying the files. We don't need to include the dist folder, we don't need to include the node modules, and we don't need to include Cypress. Another way of excluding these directories is by creating a new docker ignore file. So not dash, but docker ignore file, and then here it's going to say text, okay, this just doesn't recognize the extension. The extension is not a problem. If I open docker ignore, I can say node_modules, and I can say dist, I can say build, and here maybe other directories. I'm not going to add Cypress because, well, just a matter of preference. Actually, for our Dockerfile here, we are just copying the folders that we need. So instead of copying everything, we are picking only the folders and the files that we need for our production image. Now this is an advantage because it leads to a smaller image in the end. Once I'm done copying the files for production, I can simply run the command npm run build like so. And this is going to build the files for production, and it's going to output the files within our dist folder. So we can now come to the second step, which is to serve the production files via an HTTP server. So here we are going to start with nginx. And so we just pull the basic version of nginx, or we are not going to care too much about tags here. And all we need to do is copy these files that were output by the build command. We need to copy them into a very specific folder within the nginx image, or within the nginx file system. So this is the folder. It's user share nginx html. And here we need to copy some stuff into this folder, right? So, but we need to copy from the previous stage. So there are two options here. First option is I can use a named build. So I can say from node :firmium alpine as stage 0, let's say something like so. So I'm just naming this whole process as stage 0. And then here I would say -- from equals stage 0. That's one possibility. The other possibility is to simply omit this and use what is called an unnamed build, and we'll say just from 0. Okay, I'm going with the second one here. It doesn't really make any difference at this stage, but we need to inform which directory we want to copy. Now remember, all our files are under the dist folder, and in Docker, if we inform a directory, it's going to copy all its contents, but not the directory itself. That's why here, for example, I say copy source into the directory source, right? Because if I were just to say copy source into dot, it would copy all the contents of the source directory, but it would output all the files in our /app directory, and that's not what we want. Here, we want to copy all the contents of the dist folder into our specific nginx folder. Now, which folder do we want to copy from? Well, we are in the /app working directory here in our first step of the build. So we want to copy from /app, and then we know that the build files, or the production files, are output within the dist folder. So we just want to copy from /app /dist into our nginx folder. And that's all I need for this Docker file. I will save all the files here. Let's go back to our terminal. I'll clear the console. And now I just want to make sure that, yes, Docker is installed in my machine. If it's not installed in yours, you can get it downloaded, Docker for Mac or Docker for Windows, or follow the specific version or the specific instructions for Linux. But here I can simply say docker build, and I'm in the web client directory, so it's going to automatically identify our Docker file. And I want to tag this as, let's say, Laudermüller / unsocial web client, like so, dot. Okay, once I run this command, it's going to build our image and it's going to tag it as lauromiller / unsocial web client so that I can then run using this tag here instead of having to copy the container or the image ID. I will simply press enter here, and if you're curious about this somewhat newer version of this output of Docker, this is because Docker in the recent or in the latest versions is using this Docker build kit for building the images, and this changes a little bit the output. If you want to run a Docker command without using the Docker build kit, you can simply turn this off as an environment variable. So you can say Docker build kit equals 0 before running your command docker build blah 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 blah. Okay, this is just if you are curious why the output is different and maybe you have an incompatible version or something like this. But for us here, it's going to work just fine to have this command like so. Maybe you are also a little bit not familiar with the output, but in any case, these are the newer versions of Docker. Perfect. As you can see, everything ran smoothly here. We have our image. We have the image tag to our tag that we provided in the beginning. I will copy this. I'll clear the console. And now I can simply say docker run and then the name of the image. And of course, we need to do a little bit of port mapping here because we need to somehow access the Docker container. And for that, we need to map a port from our machine to the Docker container port. And this is done with the P flag. And we'll say 8080 is going to map to port 80 because 80 is the default port that nginx opens to provide the files in an HTTP or in its server. Once I execute this command, let's see the output. Perfect. We see that it's running, configuration complete, ready for startup. So let's go to the browser and let's try to access our production files. Back at our browser, remember in port 9000 we were running the development version. I stopped the development version. So if I refresh this page, I'm going to get some errors. But let's open a new tab and here we will access the localhost port 8080 that we just exposed with our docker run command. Once I access this localhost 8080, you will see that it now serves the file with "we are in production." And this is exactly what we wanted. Let's go back to our terminal and let's start up again the development version. I want to show you a few differences in the files that we are serving. Back in the terminal, I will leave this instance running of Docker, so I could also run this in detached mode, which would run in the background, meaning that the process would still remain or keep running until I actually kill the container. But here, let's leave this one running here. I will create a new tab and we can access or we can spin up here npm run start :dev. This is going to start the development server. Perfect. So now if I refresh the page, again, my application is not crashing. And let's have a look at a few differences. Two differences actually that I want to show you. First one is this little React dev tools here at the top. So if I click here, you will see that it says this page is using the development build of React. I'm sorry for the small letter here, but this one I cannot really zoom in. If I come to my production version, you will see that the icon is slightly different. And once I click here, this will say this page is using the production build of React. This is the first difference that I wanted to show. The second difference, let's open our developer tools, and in the network, I will refresh this and let's have a look at the size of our bundle.js file. So the bundle.js file for development has 337 KB. And let's compare this with the production version. So in the production file here or the production window, I will open this again and I will refresh. The bundle.js file has just 129 KB. This means that the files were minified, right? Remember, we added that Tensor plugin, and the job of that Tensor plugin was to minify the build for production. So the build here is minified. It's roughly a third of the size of our development build. These are the two differences I wanted to show you. And with this, I think we can safely complete the final step of this video. And that's it that I wanted to implement with you today. Let's go back to the terminal. We will now stop running the development server. We will also stop running our nginx server, and here we can close this. So let's just clear the console. I just want to commit these changes, push them to GitHub, and merge them into master. So here, let's first run a few commands. I just want to make sure that the files are correctly formatted and that there are no linting or TypeScript errors. Give it a couple of seconds until it outputs something or nothing. Let's see. And then we run the tsc check command. Everything is in order. Let's add everything as a staged change and check the files that we're going to commit. Okay, everything seems in order. So just commit this with a tag of feature for the web client. It's going to say add production scripts and Dockerfile. And that's all I wanted to do for this video. Let's just have the commands running here. We will push this to GitHub, go back there and merge these changes into master. Back in GitHub, let's compare our new branch with master. Everything should be fine. I mean, I think we should be able to merge this. And let's just quickly double check the changes here. So the types node, it got this small caret here that I don't really like. We can remove this or we can leave this to renovate. It doesn't matter. This is because we ran that command, but as it turns out, the dependencies were already installed, but we were merging, we were missing this node instruction here in our types in the tsconfig JSON. In any case, I'm just going to leave it like this. Let renovate take care of it. No problem. The changes seem good to me, and I'll create a pull request here. Once the checks pass, we will then be able to merge it into master. Perfect. Squash and merge, confirm squash and merge, and we are done with what we wanted to implement in this video. That's it for today, and now we have a full setup from development to production. This is the last video for the playlist about setting up a React application with Webpack and TypeScript and the other tools. But if you are following the unsocial app application, in the next video we are going to test how this React front end can be connected to our authentication service. Again, this is just going to be a quick test. We are not going to do even a commit for the video, but I just want to show you how it would look like if these two services were working together. If you want to be notified when this video is out, then subscribe to the channel and you will get a small reminder once I publish it. And your feedback as well is very much appreciated. So let me know if I'm going in the right direction. Maybe there is another topic that interests you. Just let me know in the comments, or some tips. Could also be some criticism, constructive please, right? So no unnecessary critics here. But of course, I'm always happy to read what you think about the channel, what you think about the videos, and how I can improve. As always, thank you for your time, and I'll see you in the next video. Bye bye.